Hey there, it's Leo again, founder of Ascend AI. Before we dive in, I just want to leave you with a quick thought. If you've ever watched a slick AI demo work like magic, only to fall apart the second you plug it into your own systems, if you connect it to your CRM, if you connect it to your marketing tool, your warehouse tool, or whatever that is, then you're in the right place. You see, this episode is going to clear the air on why your AI tools seem broken when they're actually not, and crucially, how to fix everything without rebuilding your tech stack from scratch. You'll walk away with a crisp view of what actually breaks in production, and hint, it's really the AI itself. You'll know the hidden traps even seasoned teams miss. And crucially, you'll also have a practical game plan that can get your tech stack talking so smoothly so they can start generating revenue like it's supposed to do. This isn't a hyped up episode, by the way. It's actually part of our 5-step integration audit that we run with our D2C founders and clients at Ascend AI. And it's the same framework I would use if you were our client. I stand by it, and I'm confident it'll be useful for you too. So by the end of this whole episode, if anything resonates, if you have any questions, thoughts, or things that you need to clarify or have, just reach out to me on LinkedIn or X. And if you want us to scale your revenue with AI reliably, drop us a note. All these links are mentioned below. And also, I'm actually trying a new format here for the show that's a bit different than the previous 2 episodes. So let me know when you think. I'm actually really, really curious. And that's it. That's it for the intro. I hope you'll enjoy the show. Enough me talking. I would love to welcome you now to the No Code Founder Podcast.
Today, we're diving into something a lot of teams are bumping up against. We call it the AI Vanishing Act.
Right.
You've probably seen it, maybe even lived through it. You get a demo, the new chatbot or, some automation tool looks absolutely fantastic.
Yeah, super impressive in the sandbox.
Fast, persuasive, handles everything you throw at it perfectly. But then the moment you try to connect it to the real world, your, let's say, 15-year-old CRM or that busy warehouse system, your global support tickets, the magic just poof. It evaporates, it slows right down, maybe it duplicates orders, or sometimes it just fails silently. No warning.
And you're left scratching your head.
Exactly. So the big question is, why does that brilliant AI seem to disappear when it hits the messy reality of production?
It's a super frustrating situation.
Yeah.
But the thing that often gets missed is where the actual failure is happening.
Okay.
Most of what people call AI problems, the slow speed, the messed up data, dropped chats.
Yeah.
They're almost never really model failures. That expensive LLM you're using, it's probably doing its job just fine.
Okay, so if it's not the fancy algorithm, what is it that's actually bringing the system down?
It's integration failure. Almost always. Think of the core AI, the LLM, as just one stop on a really complicated road trip. The whole thing collapses because of the plumbing.
The plumbing.
Yeah, the connections between systems, poorly managed APIs, brittle data bridges, the way the LLM actually talks to everything else in your tech stack, that's where it usually breaks.
So the answer isn't always throwing more money at bigger models or crafting the perfect prompt. It sounds more like good old-fashioned engineering discipline.
Exactly. It's about building sturdier connections, making sure you can actually see what's happening across the system, and having a solid process behind it all.
Right.
So our mission today is to kind of cut through that messy reality. We want to lay out the 4 most common, let's call them integration hell scenarios that we see wrecking these AI deployments.
Okay.
And then give you a practical, maybe like a 6-week roadmap to build systems that are actually robust and ready to handle real-world scale.
All right, let's start with that gap between the demo and the real world. You called it the single bot illusion. In the demo, the bot's basically just chatting, right? Generating text.
Pretty much.
But in production, it's suddenly juggling a whole bunch of tasks. It's like complex choreography, isn't it? It's reading a customer profile from the CRM, maybe trying to start a payment process, checking inventory somewhere else, updating, 3 different internal systems all at once.
Yeah, that simultaneous, often invisible complexity.
Yeah.
That's what just overwhelms that star performer from the demo.
And I guess it gets worse if you try to run more than one.
Oh, instantly. If you scale beyond just one agent, that complexity just multiplies. You get coordination messes. And that's when you start seeing failures that we call quietly drifting.
Quietly drifting. That sounds sneaky.
It is, because the system doesn't blow up with a big error message. Instead, maybe one agent uses slightly stale data from cache, say, inventory info from 4 hours ago.
Yeah.
It makes a decision that looks okay, like confirming something's in stock. But it's technically wrong based on the real-time data. And you only find out hours later when a really unhappy customer calls or, blasts you online. Not because your system flagged an error right away.
Ugh, that's a visibility nightmare. So if the problem really is the plumbing, the connections, what's the number one immediate, maybe even non-technical thing we can do to just get a handle on those pipes?
The service catalog.
Yeah.
Seriously. It sounds simple, maybe even boring, but it's probably the single most important piece of documentation for anyone integrating AI.
Documentation always feels like a chore.
I know. But this forces teams to be disciplined. It creates that single source of truth for all the connections. What talks to what? Who owns it? How does it authenticate? What are its limits?
Okay, so what specific details in that catalog actually prevent disasters later on?
It preempts them. You absolutely need to list every single external system the AI touches. Assign a dedicated owner, like a person's name. That's non-negotiable.
Right.
Spell out the data flow, what goes in, what comes out. Note the authentication type. Is it some fragile API key that expires or proper OAuth? Critically, list the specific rate limits.
Ah, the rate limit. So having that written down stops like a new engineer from accidentally blasting an API 50 times a second when the limit is 5 per minute.
Exactly. The catalog is your first defense against basic infrastructure mistakes.
Yeah.
It lets your AI team focus on the smart stuff, not fixing broken pipes all day.
Okay, documentation sorted. Let's get into the real-time breakdowns. Those 4 integration hell scenarios.
Yeah.
Scenario 1, the classic killer of voice bots latency, that awkward pause.
Yep. Scenario 1. The cause, like you said, it's that chain reaction.
Yeah.
Speech to text conversion.
Huh?
Then the LLM needs context and time to think, generate the response.
Right.
And then text to speech turns it back into audio. Each one of those hops adds delay.
So you need a budget for each step.
A human-centric latency budget. You got to be tight.
Right.
Like STT, aim for under 120 milliseconds. LLM processing, keep that under 150 milliseconds if you can. And TTS, maybe under 110.
Wow, that's aggressive. Why chase every millisecond?
Because the total time from when the user stops talking to when they hear the start of the reply cannot go over about 400 milliseconds.
400 milliseconds. Why that number?
It seems to be a kind of psychological threshold. Go over that, and the human brain registers it as an annoying lag. The feeling of a real conversation just shatters.
That explains so many bad chatbot calls. But what if the AI needs more time? Like it has to look something up in a slow, old system.
Yeah, good question. You can't just have dead air, so you use a degrade gracefully tactic.
Meaning?
Instead of silence, the system inserts a little programmed phrase. Something like, okay, let me check on that for you, or got it, just one moment.
Like a verbal placeholder?
Exactly. It sounds natural. Humans accept that kind of short filler phrase. And crucially, it buys you an extra second or two of processing time without breaking the conversational illusion.
That's a neat trick. Okay, scenario 2. Disappearing messages. This sounds like trouble for anything asynchronous, like webhooks.
Huge trouble.
Yeah.
Yeah, the sending system, maybe your AI agent thinks, job done, sent the request. But the receiver on the other end silently failed.
Why would it fail silently?
Could be anything. An expired authentication token, maybe it hit its rate limit, maybe the other service just had a temporary hiccup. The point is, the sender doesn't know it failed.
And the business action, the refund, the order update just never happens.
Never happens. We call it failure by silence. The fix. First, a technical safety net. Retries with exponential backoff.
Explain that.
If the first attempt fails, you don't just give up. You wait, say, 1 second, then try again. If that fails, wait 2 seconds, try again, then 4, then 8.
So you give the struggling system time to recover.
Exactly. You progressively back off, giving it a chance. But what if it keeps failing after, say, 5 retries? You can't just lose that data, especially if it's important.
Right, like payment info or compliance stuff.
Precisely. For that, you absolutely need a dead letter queue, or DLQ.
Oh, what now?
A dead letter queue. It's basically a safe holding pen for messages that failed all the retries. They land there so a human can investigate later, figure out what went wrong, and potentially reprocess them manually. It's essential for anything critical.
Okay, DLQ, got it. Any simple action item here?
Yeah, a daily health check. Just a tiny test message you send through your main integration pipelines every morning. If it gets stuck, you get an alert before real customer transactions start failing.
Proactive checks, always good. All right, scenario 3, memory loss. The bot suddenly forgets who I am or what I just asked. Super frustrating.
Instantly kills the user experience. It often happens because the conversation state gets lost as the request bounces between different internal tools or microservices.
So how do we give the bot a persistent memory?
Technically, you store a small chunk of data, usually like JSON session state, in a really fast, dedicated storage place, something like Redis or Firestore, and that state needs to be accessible to every step in the workflow that needs it. That's the bot's short-term memory.
Makes sense. Is there an organizational piece to this too?
Definitely. You need organizational rigor. Give each AI agent, if you have multiple, a really clear, defined role and ownership. Stop them from messing with each other's context or memory. Keep things clean.
Got it. Scenario 4, data format problems. This sounds like old tech meeting new tech.
That's exactly it. Your legacy inventory system speaks, I don't know, ancient XML.
Ha, right.
But your shiny new AI workflow expects perfectly structured JSON. What happens?
Data gets lost in translation.
Fields just silently drop.
Yeah.
Maybe the shipping address vanishes because the AI parser choked on the old format. The fix is about standardization. First, define a canonical schema.
What?
A canonical schema is your official internal dictionary for what data should look like. What fields does a customer object always have? What about an order? Everyone has to stick to that internal standard.
Okay, agree on the format. What else?
Second, you have to aggressively validate incoming data against that schema, especially required fields. If critical info, like that shipping address, is missing or malformed, stop the process right there. Alert the team. Don't let bad data flow downstream.
Stop it early. Okay, those are the big four. Now, you mentioned a couple of sneakier failures. The first one sounds complicated. Idempotency.
Yeah, it's a mouthful. But the concept is simple and absolutely critical. Idempotency is just a safety measure, ensuring that doing the same action multiple times doesn't have unintended side effects.
Like if I accidentally click the Pay Now button twice because the website is slow.
Exactly. Without idempotency, that could double charge you. Or maybe a network glitch causes an order submission request to be sent twice. You don't want two identical orders processed and shipped.
That sounds like a financial and logistical nightmare. How do we implement this safety?
It's usually pretty straightforward. You include a unique idempotency key. Just a unique string or ID with every request that makes a change, a right action. The receiving system checks. Have I seen this unique key recently? If yes, it knows it's a duplicate retry and can safely ignore it, maybe just returning the result of the original request. If no, it processes it normally. Tiny fix, huge safety impact.
Essential. Got it. Sneaky failure number 2. Time zones and timestamps. The classic developer headache.
Oh, this bites everyone eventually. You have servers in different regions, systems using local time, then daylight saving kicks in.
And suddenly you're getting support tickets for orders that seemingly haven't happened yet.
Exactly, or things are lagged completely out of order. It creates absolute chaos for logging, debugging, and coordination.
So what's the golden rule, the non-negotiable fix?
Store everything internally in UTC. Coordinated universal time. No exceptions.
Everything.
Everything on the back end. Timestamps, databases, logs, internal messages, all UTC. You only ever convert it to a local time zone at the very, very last step, which is usually displaying it to a user in their browser or app. Never let local time influence your core logic.
Solid rule. Okay, things will break eventually, even with these fixes. We need a rapid repair mode. What's your go-to debugging flow, like a 5-step process?
Yeah, a quick mental checklist. Step 1, check the run history first. Before you panic or guess, look at the execution logs for that specific transaction. Are there obvious errors, timeouts, rate limit warnings? Often the answer is right there.
Okay, check the logs. Step 2.
Test step by step. Try to isolate where the break is happening. Can you trigger just the first action? Does that work? Okay, trigger the second one. Does that fail? This helps you pinpoint which connection or external system is the culprit.
Makes sense. Once you find the broken step, what's step 3?
Validate the data shape right at that point. Is the data coming into that failing step look right? Or is it malformed, missing fields? Maybe you need a quick transformation step like a formatter node to fix it before it proceeds.
Check the data itself. Step 4.
Token validity, especially if you're dealing with APIs that use expiring tokens for authentication. Don't wait for them to hit 100% expiry. Proactively refresh them when they reach, say, 80% of their lifetime. Prevent the failure before it happens.
Smart. Proactive refresh. And the last step? 5.
Respect rate limits. If you're hitting an external API too hard, it'll shut you down. So cache data you look up frequently. Batch requests together if the API allows it. Make one big call instead of 50 small ones. Sometimes even just adding a tiny delay between calls can help.
Okay, that's a solid debug flow. But, preventing fires is better than putting them out. A lot of this sounds like it comes down to process and people, not just tech.
Absolutely. The non-technical fixes are often the real leverage points, but they're also often the weakest link. The number one thing, clear ownership.
How do you enforce that?
Implement something like the RACI model. Responsible, accountable, consulted, informed. For every single integration point, every system it touches, there must be one clearly accountable owner. If that CRM connection breaks at 2 a.m., there should be zero confusion about whose phone rings.
No finger pointing. Got it. What else on the process side?
Simple change management. No more cowboy coding on live integrations. Even for small tweaks, require a super simple change request form. Just something that forces a moment of review. Does this change impact anything else? It prevents so many accidental outages.
A little friction for a lot of safety. Makes sense. And testing.
Safe testing using staging environments, crucially with synthetic data.
Why synthetic, not just anonymized real data?
Because synthetic data lets you ethically and safely simulate the absolute worst-case scenarios. Massive traffic spikes, impossible dates, malformed requests, things you'd never want to happen in production but need to test for. You can break things safely in staging without touching real customer info.
Break it safely before it breaks for real. Love it. Now, for the managers or founders listening, maybe they're not deep in the tech weeds. What are the key health metrics, the golden signals they should be watching?
Yeah, the high-level dashboard. 4 things, mainly. 1, latency, but broken down by step. Where's the time actually being spent?
Okay.
2, error rates.
Yeah.
Again, broken down, which system is failing and why. Is it authentication errors? Timeouts. Knowing the reason is key.
Right.
3, 3, throughput. How many requests per minute are we actually handling? Is it meeting expectations? And 4, super important for AI, token usage and cost. This is your direct line to the financial health of the AI component. Is it suddenly costing way more than expected?
Latency, errors, throughput, cost. Got it. But if the AI talks to the LLM, which calls the CRM, which hits payments, how do you actually see that whole chain? It crosses so many systems.
That's where production-grade observability comes in. You need tools that can trace a single request across all those different services. Things like open telemetry are becoming standard for instrumenting your code. And then you send those traces to a platform like Datadog, Sentry, Honeycomb. Crucially, for the AI part itself, you need tools specifically designed for LLMs like Langsmith or Arise AI. They let you connect the detailed LLM interaction history with those broader system traces. Full end-to-end visibility.
Connecting the AI brain to the system body. Okay, before we hit the roadmap, any quick architectural mistakes people make that quietly cost a fortune?
Oh, yeah. First, workflow jamming. Don't cram dozens of unrelated, complex workflows onto a single automation tool instant just because you can.
Why not?
It creates hidden dependencies and resource contention. If one really heavy workflow goes nuts, it can starve the others and bring unrelated things down. We usually suggest maybe limiting it to, say, under 20 distinct workflows per instance, especially critical ones. Isolate failure domains.
Keep things separate. What else?
Lack of failure testing. I know we mentioned it, but it bears repeating. You must simulate failures in staging. Timeouts, bad credentials, hitting rate limits. Do it before you go live, not after.
Test for failure. Third,
context stuffing. Resist the urge to just shove the entire conversation history, plus maybe a huge knowledge base article, into every single call to the LLM.
Why is that bad?
It kills performance, makes the LLM slow, and it dramatically increases your token costs. Be surgical. Send only the context truly needed for that specific turn in the conversation. Keep the context window lean.
Lean context. And the last mistake.
Premature multi-agent architecture. Teams get excited and want to build lots of specialized little AI agents right away. But managing the state, coordination, and error handling between them is hard.
To start simple.
Absolutely. One solid, reliable agent doing a core job well is infinitely better than 5 confused, slow agents stepping on each other's toes. Nail one core workflow, make it bulletproof, then think about specializing or adding more agents.
Nail the basics first. Okay, great advice. Let's bring it home. For the listener who's thinking, okay, I need this reliability, where do I start? Give us that 6-week roadmap.
All right, actionable steps. Week 1, map your stack. Seriously, build that service catalog we talked about. Document every connection. And crucially, formally, decide your sources of truth. Where does the official customer record live? Where's the master order data? Get that foundational map clear.
Week 1, map it out. Week 2.
Week 2, choose one key workflow. Don't try to boil the ocean. Pick one important, maybe currently painful workflow. Post-purchase support is often a good candidate, and define clear success metrics for it using those golden signals, target latency, acceptable error rate, etc.
Focus on one workflow. Week 3.
Week 3, build or refine in staging. Implement the workflow, paying close attention to the connections, use synthetic data, and this is key. Rigorously test the failure modes. Simulate API timeouts, simulate bad data, simulate auth failures. Break it on purpose here.
Build and break in staging. Week 4.
Week 4, add observability and safety nets. Instrument that workflow. Set up monitoring for your golden signals. Configure alerts so your team knows about problems before customers do. Implement the DLQ if needed.
Monitor and alert. Week 5.
Week 5, pilot test. Don't just flip the switch to 100%. Roll it out cautiously. Maybe start with 10% of traffic or a specific user group. Watch those dashboards like a hawk. See what real-world weirdness occurs and refine your error handling based on that.
Pilot carefully. And finally, week 6.
Week 6, scale up. If the pilot looks stable, gradually open the gates 50%, then 100% for that chosen workflow. If you did the first 5 weeks with discipline, this week should mostly be about continued monitoring and maybe some optimization, not frantic firefighting.
That's an incredibly practical roadmap. Map, choose, build, break, observe, pilot, scale. It really drives home the core lesson, doesn't it? Success with production AI isn't really about some magical new model.
Not primarily, no.
It's about discipline engineering, clear documentation, robust processes. It sounds like the infrastructure, the plumbing, really dictates whether the intelligence can actually succeed in the real world.
That's the absolute truth. The infrastructure provides the foundation. Without a solid base, the smartest AI in the world will just stumble and fall.
So maybe a final thought for everyone listening.
Yeah, perhaps this. If you had to pick just one thing to absolutely guarantee before you try to scale any significant AI integration, it wouldn't be tweaking the model prompts one more time.
What would it be?
It would be verifying 2 non-AI things.
Yeah.
First, that idempotency keys are correctly implemented on every single action that changes data, preventing those disastrous duplicates. And second, that your service catalog is accurate, up to date, and actually verified by the owners of those connected systems. Those 2 things provide the bedrock.